Okay, lesson 1.3. We're going to kind of change it up a little bit. 1.3 isn't necessarily talking about transformations. 1.3 is working with lines, right? Linear functions, modeling with linear functions. Linear means line. So, let's get right into it, shall we? What we want to do is, well, we actually have this word problem. A company purchases a copier for $12,000. The spreadsheet shows how the copier deprecates over an 8-year period. Okay. Write a linear function to represent the value v of the copier as a function of the number of years t. Okay. So, what I first want to start with is this equation here. Y equals mx plus b. We should have all seen this. We should all know this equation. Okay, this comes back from 7th, 8th grade pre-algebra. Y equals mx plus b. This is what we call slope intercept form. Slope intercept form. The reason for that is we have a slope in this equation, and which letter represents the slope? That would be m. And we have an intercept. We have a y-intercept. And which letter represents the y-intercept? It's b. Okay, so we're going to be using this equation in this problem here. We want to write a linear function to represent the value v of the copier as a function of the number t of years. Okay, so we have t and v. Well, we know that v is our value. Okay, and I'm just going to be fancy here. We're going to say v of t. I'm okay if you just have v. That's okay. Okay, I'm just being a little fancy. Okay, and we start off with $12,000. Okay, at year 0, we have $12,000. Okay, well, $12,000. That's where we're going to start off. That's our y-intercept, right? 12,000. Okay. Now, look over at our chart. Each year, how much does it go down? Well, from year 1 or 0 to year 1, it looks like it goes from 12,000 to 10,750. That is, quick math, $1,250. Right? $1,250. The next one, from year 1 to year 2, that's down, how many? $1,250, right? It looks like it goes down $1,250 each year. So I'm going to write that, 1,250 for t years, right? That's, make this a little nicer. 1,250 t plus 12,000. Now, is it going up or down? Is the value going up or down? The value is going down, right? So we're going to have a negative $1,250. And this is kind of a tough problem to start out with. We'll get into it a little more here, down here. I'm just going to move this equation over, because that's what we use in here. Okay. Sketch a graph of the function. Well, this is where I'm saying we have an intercept, right? Y-intercept, $12,000. So these are all going to be in thousands. I'm just going to write that. Okay. Each one is going to go up once. So there's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So these are all in thousands. My y-intercept is right at 12,000. Okay, my years are all in one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay, those are my years. This is my price. We can write that. We can write what is the actual? It's value. Okay, value. So we'll say value in years. And we have to go down 1,250 each year. So just as carefully as you can. Right there. Right there. Here. Okay, I'm not being exact, but there is our equation. It's going to continue down. Okay, because my slope was minus 1250. So from each point, I went down $1,250. Okay, down $1,250. $1,250. Okay. Interpret the slope of the graph. We talked about it. Okay. This next exploration, we are matching each description of the situation with its corresponding graph. All the graphs are down here. Okay. A, B, C, and D. We're just going to match A, B, C, and D with the correct graph. So number one, a person gives you $20 per week to pay a friend to repay a loan or a $200 loan. Okay. Pick out the important information. $200. Which slope down or which graph down here has the number 200? Well, we know B has the number 200 in the graph. We know D has the number 200 in the graph. Okay. But it's $20 per week. So if I were to think of that graph, think of good numbers here. What's another good number? How many weeks would it take for the loan to go down to $100? Well, it'd be 5, right? Because 20 times 5 equals 100. So at week 5, we should be at 100. So I'm going to go to graph B. Look where number 5 is. Right here. If I go up, look where it's at. It's at 100. So you know that this graph up here, this is going to be graph B. We really don't have to do that much thinking in these. Part B, an employee receives $12.50 plus $2 for each unit produced per hour. Well, which graph starts at $12.50? C, right? A sales representative receives $30 of pay. Well, which graph starts at $30? That'd be A. And which graph is left? D. So BC, AD. Number 3, how can you use a linear function to model and analyze real-life situation? The y-intercept is the original value. Okay, the slope is the change. All right, moving on. We have a few definitions here. We have line of fit, line of best fit, and correlation coefficient. Starting with the line of fit. When the data in a scatter plot show, okay, so line of fit is when the data in a scatter plot when the data in the scatter plot shows an approximate linear relationship. Okay, so a line of fit is when the data in a scatter plot shows an approximate linear relationship. All right. Scatter plot, just to refresh your mind, a scatter plot looks something like that, right? And if you were to draw a line of fit, it looks something that goes through here. Okay? So an approximate linear relationship. There's my black line is the linear relationship. It looks like it's a positive correlation. It's going up and to the right. Line of best fit is that line that I just drew. But it's, let's see, the line that lies as close as possible to all data points. Okay, so again, if I had my scatter plot here, dot, 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 dot. Okay, and I need to draw a line of best fit. Pretend that your line is you walking down the hallway, okay, and all your friends or buddies are on both sides of you, and you want to reach your hands out and hit as many as you can. Okay, that's the line of best fit. Something like that. Now, my line of best fit probably won't be exactly the same as yours. Okay, it's kind of an approximation, which is okay. But we want to get as close to the middle as all those points as possible. And correlation coefficient. I'm not going to talk about that definition. We won't use that very often. Scroll down. Next says 1 through 3. Use the graph to write an equation on the line and interpret the slope. Okay, so we want, I'm just going to use this equation. Y equals mx plus b. Use that equation. Okay, what does b stand for? B is the y-intercept. Okay, well, what's my y-intercept in number 1? Where does it cross this line here? My line crosses right here at 50, right? So my equation is going to be y equals something x plus 50. I have my b. My m is my slope. Slope. How can you find slope? Well, it's rise over run. So from point 50 to go up to this point here at 1051, how far up did it go? Well, it went from 50 to 1. So it went up 1. How far over did it go? Well, it went from 0 to 10, so it's 1 over 10. There's my equation. How about this one? Part 2. Well, where does it cross the y-intercept? Right at 360. So y equals something x plus 360. How far down did it go? Well, from this point here to this point here, the y-intercept to the x-intercept, it went down 360. So negative 360 over how many? Well, went from 0 to 6 over 6. You can simplify that equation. Negative 360 over 6 is 60. I just simplified that fraction. Part D, I'm going to erase this stuff down here because we're going to need more room on this one. This is a little different. Okay, can you tell me exactly where that y-intercept is? Can you tell me exactly where that y-intercept is? No, you can't. You can take a guess, right? You can say probably, oh, it looks like it's 78. But what if it's 78.5? Hey, we don't know. We don't know. We have to find that. We don't know what b is. Do we know the slope? Yeah, we can find the slope, right? From this point here to this point here, it goes up 10 over 10. So up 10 over 10, which is what? Just 1? So we can say up 10 over 10 x, but that just simplifies to 1. So I'm just going to write x. I'm going to write b plus b. We don't know what b is. We have to find b. We have to find b. Well, how can I do that? How can I do that with just this equation? We have 3 missing variables. The trick is to take one point. I'm just going to take this point, 10, 85. Okay, I have my x and I have my y. Plug that into my equation. 85 equals 10 plus b. Subtract 10. Solve for b. We get 75 equals b. Not done. I just found b. Not done. I'm going to plug it back into my equation. Y equals x plus 75. Done. If you don't know the y-intercept, you have a little math to figure out. Down here, number 4, the cost of parking in a parking garage in Chicago is represented by the equation y equals 15x plus 20, where y is the total cost in dollars and x is the time in hours. Okay, the table shows the cost. Okay, so up here's the equation for Chicago. Here's Chicago. The table down here shows the total cost to park in a parking garage in Denver. So the table is Denver, the equation is Chicago. The question is, which city's parking garage charges more per hour? And by how much? Okay, so I'm just going to look at my graph. What do I know about any one of these? Well, I know that Chicago, I can find any time, right? I can just plug a number in for x, find the value for y. Denver, I only have a select few. I have 2, 3, 4, 5. Well, let's look right here. 2 hours, $43. Okay, well, let's plug that in to my Chicago time. Y equals 15. Let's plug in 2 hours just to compare. And, well, how much does it cost in Chicago? Y equals 30 plus 20. Y equals $50. So to park in a parking garage in Chicago for 2 hours, it's $50. Holy cow, that's expensive. I don't have $50 to go park my car. I'll walk. $50. Okay, how much does it cost in Denver for 2 hours? 43. So which one's more expensive? Chicago. And by how much more? $7 per hour. $7 more per hour. The next question. After how many hours would parking in both cities cost the same? Okay, well, if I look up here, each time it's going up $7. Hour 3, we're just at 51. Well, that's going to bump up in Chicago. right? Let's find out 1 hour. Okay, let's find Chicago's 1 hour. Well, that'd just be y equals 15. We can say times 1 plus 20. But that's really just equal to 35. Okay, so that's 1 hour in Chicago. What is it for 1 hour in Denver? In Denver, it looks like it goes down how many dollars per hour? Or up, I guess. Looks like it goes up $8 per hour, right? 43 to 51, that's $8. 51 to 59, that's $8. 59 to 67, $8. So, what is 1 hour? Well, it's 43 minus 8. That is 35. So 1 hour. It would cost the same. Alright, so that's just analyzing an equation, analyzing a chart. Not too bad. Down here, I'm going to do 2 of these with you. Okay, the other, excuse me, the other one will be on you. It says, use the linear regression feature on a graphing calculator to find the equation of the line of best fit, blah, 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 blah. Find and interpret the correlation of the coefficient. Instead of doing that, I am going to do the line of best fit in my own way. Okay, it might not be perfect. And I'm going to come up with the equation for that line of best fit. Okay, so number 5. Let's do this one. This is a pretty difficult problem. I need the line of best fit through there. So I'm going to take my line. My line might look better than yours because I have technology. And I'm going to go through all 4 of those points as best as possible through the middle. Okay, that looks close enough. Okay, so something like that. Now, I want to find 2 points. Actually, it might be better just to do something like that. Yeah, perfect. Right there. On my line of best fit, I want to find 2 points where it crosses my graph in like kind of easy points, right? What I'm trying to say is I don't want to pick this point here because I know it's at 2 something. Right? I don't know what my y coordinate is. I want to pick an easy point. So I see this point here. That is at point 4, 3. And I see this point here, which is at 10, 2. Now I want to find an equation. I want to find the equation of that line. That's what I want to do. Y equals mx plus b. I don't know what b is, but I know my slope. My slope, it looks like it goes down 1 and over 6. Now I have to find b. Again, this will be a little different than yours. Maybe your line of best fit looks a little different than mine. Okay, but this is what I have. Plug a number in for x and y. Doesn't matter which point. I'm going to choose this one right here. 4, 3, where I have my x and my y. So 3 equals negative 1/6 times 4 plus b. Now, solve for b. 3 equals negative 4 over 6 plus b. 3 equals negative 2 over 3 plus b. We have to add 2/3. So 3 plus 2/3 equals B. That's just 3 2/3, right? 3.6. 3.6 repeating. So I'm going to go back and I'm going to plug that into my original equation. My equation of the line of best fit is y equals negative 1/6 x plus 3.6. Now, what did the question ask here? It said, find equation of the line of best fit, which we did, and interpret the correlation. I'll write that here. How would you interpret that correlation? Well, it's not a very strong correlation. Really, there's really not a whole lot to be said about this scatter plot. So we'd call that a weak. Okay, and we call it a weak negative correlation. Okay. I'm going to do number 7. Number 7 with you. So number 6 will be on your own. And again, I'm going to find the line of best fit. I'm going to go through each and every one of these as best as I can. Cool. I'm going to delete that one. Okay. Let's see here. I'm going to go through all 3 of these, or all 5 of these, whatever it is, as best as I can. Okay. Yeah, let's go. Now, I want to find points on my line. Points on my line of best fit. There's a point there at 1, 1. And we'll go with this point here. That's actually data point, but that's okay. That's at 6, 4. Now, come up with my equation. Y equals nx plus b. Again, don't know what b is, going to have to solve for it. What's my slope? It goes up 3 over 5. So y equals 3 over 5x plus b. Choose a point. I'm going to choose 1, 1, because those are easy points. 1 equals 3 over 5 times 1 plus b. Subtract 3 over 5. Okay, so I'm going to say 5 over 5, because that's 1 minus 3 over 5 equals b. I get 2/5 equals b. So my equation on my line of best fit is y equals 3/5 x plus 2/5. Going back here. Describe the correlation. Because my line of best fit was really, really close to all of those, that is a strong correlation. It's a strong, which direction? It's going up and to the right. That's positive. Okay. Number 6. I'm not going to do a line of best fit, the equation for it, but lines are really close together. Dots are really close together, right? Really close to that line. That's a strong, it's going down and to the right, so that's a strong negative correlation. Okay.